All right, we're back here, wrapping up section 2 and chapter 12. We're going to talk about the relationship between two categorical variables. Are people who are prone to sudden anger more likely to develop heart disease? An observational study followed a random sample of 8,474 people with normal blood pressure for about 4 years. Okay, so each person took the Spielberger Trait Anger Scale test. It's an instrument there. Researchers also recorded whether each individual developed coronary heart disease, CHD. All right, so here we go. Here's our two-way table that we have here, and a little summary bar graph over here. Yeah, so looking at those, a lot of the different things to decipher. So, do these data provide convincing evidence of an association between the variables in the larger population? Okay, well, let's see. Our null hypothesis is that there is no association between anger level and heart disease, and our alternative is that there is an association. All right, so an equivalent way to state this would be that anger and heart disease are independent, and anger and heart disease are not independent variables, as we talk about those different ways of saying it. But all right, so here we go. So here's our two-way table. Now, if we imagine choosing one of these people at random, probability of yes is going to be 190 out of 8,474. So that's going to be our probability. Now, if we assume that the null hypothesis is true, then anger level and CHD are not, one doesn't cause it, they're independent. So the probability of being yes, given that they have low anger, so the probability of yes is going to be 190 out of the 8,000, so 0.02242. Okay. All right, so there we are. So of the 3,110 low anger people in the study, we would expect, okay, so if we were to take that, to find that as a proportion, yeah, we multiply that by there, we would expect to get 69.733, and again, our observed value there was 53. Okay, so again, we have some differences there. Okay, all right, so continuing on with this, so to get our expected count, we're going to take our row total times our column total. All right, whoops, go back, I thought they were going to do that. So we take our row total times our column total divided by the total, and we get those. Do that for each one, and so now we have our expected counts on all those. Okay, so we got those all taken care of in our chart there. Okay, so now we can move on. Now, making sure that we have conditions. Okay, we're going to check those and use our chi-square test for independence. All right, we're going to check to see if this is the case here. All right, so again, that's what we're going to try to do. All right, let's look at another problem here. Now, in Chapter 1, you've read about a random sample of winter visitors to Yellowstone National Park. Each of the 1,526 visitors in the sample was asked two questions. Do you belong to an environmental club? And then, what is your experience? Own, rent, or never use? Now, the two-way table summarizes that. Okay, so again, snowmobile experience versus being a member or not a member. Do these data provide convincing evidence of an association between environmental club status and type of snowmobile use in the population of winter visitors to Yellowstone Park? Okay, so basically we're checking the independence there. All right, so what do you think? Well, let's do the statement. We're gonna do the null hypothesis that there is no association between environmental club status and type of snowmobile use to the Yellowstone National Park. Now, the alternative is that we believe there is an association. So, yeah, so that's going to talk about its independence is what we're talking about. So we're going to use a 5% significance level when we do this. Now, again, as we do this, we're going to use the chi-squared test for independence. We're going to do a random sample. It's got to be less than 10%. It is random. And then all of our expected counts, when we do the table below, you can see that those are bigger than 5, or at least 5 or more. So yeah, we've done all those. Again, that's where you take the row total times the column total divided by there. That's how we get those. Remember how to do that. Okay, so we've got all those filled out. The do part, again, I would use the calculator. Again, show the first couple how you do it. 445, yeah, do the observed minus the expected squared divided by, that total there. Okay, so we've got all that taken care of. All right, and yeah, look at this. Holy buckets, look at that value. Now, you got to be careful, excuse me, when you look at that calculator. You peel up, you'll say, oh, it's 4.82, but remember, you're going to see on your calculator negative 26, which means times 10 to the negative 26. So we got to move this decimal 26 places there and fill in zeros. So essentially what that's telling us is that the probability of that happening is 0. It really is 0. And so that is definitely less than 0.05. So we're going to reject the null hypothesis. We're going to say that we do have convincing evidence. There is an association between environmental club status and the type of snowmobile use in the population of winter visitors. So there we go. All right. Now, when the p-value is very small, the calculator, use that sign notation. Again, make sure we're looking at those. Okay, so don't write it as 4.82 e negative 26. Actually, kind of go there. So, all right. So again, using these chi-square tests wisely, the chi-square test for homogeneity and chi-square test for independence, they're very similar. The best way to distinguish when these two tests is to consider how the data were produced. Now, if the data come from 2 or more independent random samples, then do a chi-square test for homogeneity. All right. If it comes from a single random sample of individuals that are classified according to 2 categories, then use the independence. So that's how you know when to use one or the other. All right, so let's talk about that here. So, are men and women equally likely to suffer lingering fear from watching scary movies as children? Researchers asked a random sample of 117 college students to write narrative accounts of their exposure to scary movies before the age of 13. Now, more than 1/4 of the students said that some of the fright symptoms are still present when they are awake. The following table breaks down these results by gender. Assume that the conditions for performing inference are met. We're going to say that they're all there. There's a Minitab output for a chi-square test using the data. So they put it in a computer. Minitab's a program that they use. So we're going to take a look at that. All right, so should a chi-square test for independence or a chi-square test for homogeneity be used in this setting? Explain your reasoning. Okay, so let's kind of look at that table a little bit on what we're seeing. All right, so we get some information that we have here. Again, we have our p-value, we have our chi-squared. All right, so again, we're going to say in this case we want to use the chi-square test for independence. Data were produced using a single random sample of college students who were then classified. So we put them into 2 variables, gender and whether they had lingering fright symptoms. So the chi-square test for homogeneity requires independent random samples from each population. So in this case, we want to use the independence is what we want to use. Okay, so the hypothesis for this setting, we would want to say that there is no association between gender and whether or not college students have lingering fright symptoms. And there is an association between them for the alternative hypothesis is kind of what we want to do there. All right, so which cell contributes the most to the chi-squared test statistic? And in which way does this cell differ from the null hypothesis suggests? Okay, so let's take a look and see what we see here. All right, so men who admit to having lingering fright symptoms account for the largest component of the chi-squared test statistic. That's the 1.883. Far fewer men in the sample admitted to lingering fright symptoms, 7, than we would expect if the null hypothesis were true. If it was true, that was 11.69 is what we had there. So yeah, that's the expected value. So yeah, that statistic was certainly one for the largest component. Okay. All right. So what does the p-value tell us? Okay, and what conclusion can we draw? Well, D, if there's no association between gender and whether or not college students have lingering fright symptoms, then there is a 0.045 probability, that's our p-value that we see right here, yeah, that's it, of obtaining an association as strong or stronger than the one observed in the random sample of 117 students. That's what that p-value represents. So now make a conclusion. Now, because that p-value is 0.045, it is bigger than 0.01. Okay, that's the significance test that we use. We're going to fail to reject the null hypothesis. And we're going to say we do not have convincing evidence that there is an association between gender and whether or not college students have lingering fright symptoms. Okay, so that wraps up section 12.2. Again, we have our learning targets of what we're trying to do. Again, we did some different chi-squared tests for homogeneity and for independence, making sure that we understand when is one used over the other and make sure we understand that process of the state plan do conclude. Make sure we know that and how to get that p-value and how that gives us the information that we need. Okay, until next time, I am Mr. Boone.